Okay, an airplane trip involves 3 legs with 2 stopovers. The first leg is due east for 620 kilometer. The second leg is southeast 45 degree for 440 kilometer, and the third leg is at 53 degrees south of west for 550 kilometer. What is the plane's total displacement? Okay, so first of all, you can see it wants us to find the total displacement. Total means resultant, resultant displacement. Okay. So here he mentioned about east, southeast, south of west. So we need to know this. We need to know the direction. This is north, this is east, south, and west. Okay. I see here there is a southeast. Southeast means where? Southeast means 45 degrees southeast. Between south and east, in between, which is it must be 45 degree. If we mention southeast, it must be 45 degree. If southwest, it is 45 degree also. Okay. So I just want to show you here. Southeast means this one. Okay, sorry. This is the southeast. We call it southeast. All right. So it must be 45 degree. No matter here 45 or over here similar. Yeah, 45 degree. Okay, let us draw out the vector diagram. Okay. So we have the first leg is due east. Due east means east direction in this one, yeah, to the right. So let us draw out the first leg. Okay, so due east. This is the first leg. For how many kilometer? Let me see. Due east. So it is 620 kilometer. Okay, and then the second leg, southeast. Southeast means over here lah. Southeast 45 degree. So it is over here. Okay, and it is 440 kilometer. And it must be 45 degree. Okay, and then the third leg is 53 degrees south of west. This is very important. South of west. What is means by south of west? Okay, let us first of all, we need to know about what is it mean by south of west. If the question asks about south of west or west or south, what's the difference between them? South of west or west of south. Let's say this is 53 degrees south of west. Our question here is 53 degrees south of west compared to 53 degree west of south. What's the difference? So okay, let me tell you. South of if 53 degrees south of west, it means that okay, let me tell you. South of west means okay, this is our north, east, southwest. Okay, so south of west means we look from west. We look from west first. Okay, south of west. That means we take from west. Yeah, we take from west. South of it. Yeah, south. 53 degree going south. 53 degree going south of west. So this is our direction. So this is the direction. 53 degree south of west. Okay. So but if the question says 50 degree west of south, then the angle will be, where's the angle? Where do you think will be the angle? Okay, let me draw it out. So this is northeast, southwest. Okay, so west of south, that means we look from south. We look from south, which is this one. So this is our direction. Over here also, but the angle is 53 degree west of south. So 53 degree west of south. Okay. 53 degree west of the south. Okay. This is 53 degree south of the west. Okay. Good. Now our question is 53 degree west of south. That means, where is it? That means we look from south south of west. That means this is our west. So south of west, that means it is over here. Okay, because this is our west and this is our south. So south of west, south of west. So our 53 degree is over here. Don't go to draw over here 53. This is wrong. If you draw this one, it means west of south, not south of west. Okay, so 53 degree south of west. Okay, so okay, let me just throw it off this one. So 550 kilometer. 550 kilometer. So let's draw out 550 kilometer. Okay, so how to continue from here? So find the resultant. So you have to resolve one by one. You have to resolve everything into x and y components. Okay, so you have to resolve into x and y components. Okay, so you have to resolve this one, this one, this one, this one. Okay, so we first of all, you must write the direction. Okay, we know that going to the right is positive, going up is positive, going to the left is negative, going down also negative. Okay, and then resolve it into components. Yeah, resolve all this into components. Okay, let me draw out the table first. Yeah, let me draw out the table first. Okay, so I have drawn out the table for you. Okay, so let us look at this one. First, we need to label them. Label all this displacement. Okay, so we consider this, the first leg is the this is we can say this is S1. Okay, displacement 1, and then this is S2, displacement 2, and this is S3. Okay, S2, S3. So we have how many displacement? We have S1, S2, S3. Now we want to total up all these vectors. Okay, but before we total up the vectors, we must resolve them into components, x and y components. Like you look at this one, S1, it only has x component, but S2, it has two component. It has x component and y component. S3 also has two component, x component and y component. Okay, so that is, and then we want to find the total displacement. Okay, so let us do one by one. Yeah, let us do one by one. So look at the S1. S1 is only has the x component. Okay, and it is positive. So we write here positive 620 kilometer. Okay, and then y component is 0 because it don't have any y component. It only has x component. And then how about the S2? S2, it has the x component. Okay, remember, if you have angle, you just put cos. Like this one, for the x component, it is cos. For the y component, it is using sine. Okay, remember the side which is adjacent to the angle. Adjacent use cos, and then opposite, like this one, it is opposite to the angle, use sine. This is cos, this is sine. Or you can say, just say got angle cos, no angle sine. Like here, no angle sine. Okay. So so for the x component, it is positive. Okay, so it is going to the right. So we just write positive. Sorry, put blue color, better. It is positive 440 cosine 45 degree. Make sure your calculator in degree. Make sure your calculator in degree. Don't use radian. Don't go to use radian. Be careful. Set your calculator into degree. Okay, so this is to the right, so it is positive. Okay, now How about going here? The y component is going down, so it is negative. Remember, you must put the direction. It is negative 440 sine 45 degree. Okay. Negative 440 sine 45. We still use this 45 degree. Okay, now let us look at S3. S3 is make it smaller. Okay, S3 it is going here. So what about the x component? So x component, it is adjacent to the angle. So adjacent we use cos. Okay, and then the y component, it is opposite to the angle. So it is use sine. Use sine, or you can say got angle cos, no angle sine. Okay, so look at the let us derive out the x component. Okay, so for the x component, it is going to the left. If you look at here, let me just draw it out. This is the x component, and this is the y component. These two component, x component and y component for 550. So for the x component, it is going to the right, going to the left. Going to the left is negative. You must put a negative sign here. If you don't put a negative, you are damned. So this is negative 550 cosine 53. Okay, cosine 53. Remember, set to degree, your calculator. And then about the y component, it is going downward. For this S3, it is going downward. Downward is negative. So going negative. So 550 sine 53 degree. So if the S2, maybe I also can draw it out. S2, the S component is this to the right. That's why the S2, the S component is positive. But for the Y component, it is going downward like S3. Going downward like S3. That's why it is negative. Negative. This one negative. Okay. So now you already derive out the components. You already resolve into components, S1, S2, S3, all in components. Now only you can total up the X and total up the Y. Okay, let me total up. Okay, so I calculated the X component. It is positive. I got positive value 600.1287. Better write 4 decimal place, more accurate. Maintain as many decimal place as possible. 4 decimal place, only the final answer you give 2 decimal place. Okay, and then the Y components, let me calculate. Okay, so I calculated for the Y component, it is negative. Remember, the negative sign very important, because this positive negative sign is all about direction. That means later I show you the direction. Okay, I got negative 750.3765. That's our Y components. Okay, now positive X means to the right. Negative Y means to downward. Okay, so let us also draw it. Positive X means to the right. This is positive X. Positive X. And then negative Y. Negative Y means downward. Negative Y means downward. If positive Y means go upward. Negative Y means downward. So this is our resultant. Our resultant for X displacement, it is going to the right, but for the Y component, it is going downward. So let us draw out our resultant. Okay, our resultant. So our resultant is this one. Positive going to the right, positive X. Okay, positive X. And then for the Y component is going downward. Going downward, negative 750.3 No, 3765. So this is our resultant. So we can say that this is actually total as x. This is our total as y. This is the total x component and this is total y component. So what is our resultant? Our resultant will be the Pythagoras of these two components. The Pythagoras of these two components, which is this. This is our total S. Okay. Later we need to find this angle. So theta. So how to find this resultant S? Okay. Resultant S will be the resultant displacement will be, so just Pythagoras these two components. Pythagoras the total, the total Sx. We square it, and then our total Sy, we also square it, and then we square root the Pythagoras theorem. So just substitute your value over here and here. The negative sign after square is gone. So what is our answer? Let us find out our answer. Okay. Okay, so I calculated the answer is let me see. The answer is 960.84. 84. What is the unit? It use kilometer, isn't it? Kilometer. So just put kilometer. Kilometer. That is our, our magnitude. This symbol means magnitude. This modulus means the magnitude. We call it the magnitude. Magnitude of the total displacement. So we got the answer 960.84 degree and 84 kilometer. So that's the answer. Yes, almost there. Yeah. Difference by a little bit, never mind. So correct, our magnitude is correct. But the question also, okay, this is displacement, you understand? Remember, when asked about displacement is a vector. When vector, it has what we can say, this vector, it has both magnitude and direction. Okay. So the question doesn't explicitly ask for find the magnitude and direction for the total displacement. It didn't explicitly mention want to find magnitude and direction, but he just plainly asked what's the displacement, total displacement. We must also give the direction, although it didn't ask for direction. Why? Because displacement is a vector. Vector, if you just give the magnitude, like what we find here, magnitude, you only get half the marks. Okay? You will lose marks for the directions. It's not complete. Because displacement is a vector. When he asks about what is this vector, a vector, you must give both magnitude and direction. Okay? If you didn't give direction, you lost marks for direction. Okay, so how to find the direction? That means the direction, you need to find this angle. This angle, direction, normally we refer to the x-axis. We will refer to the x-axis. Okay, you must say this, you not just find the angle, theta. You must also say this angle, the theta degree, below positive x-axis. You must mention which, mention which quadrant. Not necessarily say first quadrant or third quadrant. You just say that in terms of theta degree above or below the x-axis. Positive x-axis, is it positive x-axis or negative x-axis? You need to tell that. Yeah, you tell that. So now find direction. Okay, let us now find the direction. Okay, sorry. Let me just rub it off. Okay. Let us now find the direction. Okay. So direction, we need to find the angle theta. We use tangent theta. Why we use tangent theta? Because we already have the opposite and adjacent. Just divide them. I purposely modulus. You know what I modulus? Because we want to remove all the negative sign. Like the y component has negative sign. The negative sign will disturb the calculation. We want to remove, make it all positive. Make it all positive. So that's why we add a modular sign to remove all the negative, to make all become positive. So tangent theta is opposite over adjacent. Opposite is this one lah, negative 750.3765, and then over adjacent, which is 600 and 1287. Okay, so let us calculate the answer. Okay, modulus means the negative sign will gone. Okay. One thing is, remember, we want to find theta. We don't want to find tangent theta. We don't want to find tangent theta. Understand? We want to find theta. So what it means here is we need to do the anti-tangent. Anti-tangent, blah, blah, blah. So remember, do the anti-tangent if you want to find the theta only. We don't find the tangent theta. We find the theta. Okay, so what's the answer I get? My theta, after anti-tangent, I get 51 degree point 51.35 degree. Is it enough just mention the angle? No, you must say, is it above or below the positive x-axis? In this case, it is referred to the positive x-axis. But sometimes we also the vector go to the other side, it become you need to refer the negative x-axis. Sometimes you also need to refer the negative x-axis. Is it above or below the negative x-axis? But there is other case. In this case, we got the resultant displacement below the positive x-axis. So here you must add below 51.35 degree below positive x-axis. That is our complete direction. Okay, so is it correct? 51 degree below positive x, is it correct? Yeah, it is correct. 51.35 below positive x. Yes, 51.35 degree below positive x-axis. Okay, that's it for this question. You must give magnitude and direction. Okay, see you in the next video.